Welcome back to another video, and in this video we're going to be continuing on with our macOS development with AppKit tutorial series, and in this particular tutorial we are going to be taking a look at how we can send delete requests to a third-party API using a URL session and all that stuff. This is the last video in our this is the last video that we're going to do with network requests. So hopefully by the end of this video, you will feel comfortable being able to send network requests in Swift. All right, so what we're going to do first is we are going to fill in this method in our network manager that you see here called delete. Now, this method is going to do the following. First, we're going to create a URL object with the endpoint we want to send our request to. Second, we are going to send that delete request to the server. Third, we're going to check the status code to make sure that the status code is correct, right? Make sure that it's a 204 in this case. And then if it's not, we want to throw some kind of error. Delete is relatively simple compared to post and patch, because much like with a delete request, or rather a get request, delete requests only need to be sent to a specific endpoint, and in the URL there needs to be the data the request needs to perform that delete function. There's no body, there's no need for a content type header or anything like that. So let's go ahead and get started. Inside of Xcode, I already have my delete method here, so func delete project. It's also async, and it can throw. Let's go ahead and make sure that we have a delete failed case in our network error. And delete failed. Case dot delete failed. Return something went wrong when trying to delete the project. Cool. So now inside of our delete method, we will create the URL that we want to send our request to. So this will be guard. Excuse me. This will be guard. Let me double check to make sure my... Okay, so it'll be guard let URL equals URL with a string. And inside of this string, we'll have http://localhost 8080/API/projects/delete. Slash, and then we will use string interpolation to give it the ID of the project we want to delete. So project.id. And so if creating this failed, we want to throw network error dot invalid URL. After that, we need to create our URL request object, which is as simple as just saying var request equals URL request, pass it the URL, and then say request dot HTTP method equals delete, like that. And we're done with our request. Now we need to actually send out the request to the server. So we'll say let underscore comma response equals try await URL session dot shared dot data for our request. All right. So now that we have our request sent out, we need to get the status code by first casting our response URL response object to HTTP URL response. So if let HTTP response equals response as HTTP URL response. And if that was successful, we want if HTTP response dot status code is not equal to 204, which is a no content response. The 204 status code is what the status code will be if the delete was successful. So if it wasn't, then we know something went wrong, and we'll throw a network error dot delete failed, like that. And that's it. So let's kind of go over what we did real quick. First thing we did was we retrieved, we created a URL object using a guard let statement to safely unwrap the URL initializer. If this is not a valid URL, we throw a invalid URL error. If we were able to successfully unwrap our URL, we went ahead and created a URL request object where all we need to do is set the HTTP method property, which is an optional string, to delete, so the server knows what kind of request we're dealing with. And then after we have our URL request object created, we are sending our request to the server using URL session shared data. And we are retrieving the response that we get back, not the data, because we don't need the data that we get back. We only need the response. After we retrieve the response, after sending the network request, we cast our URL response to an instance of HTTP URL response so we can get the status code. If that is successful, we test to make sure that our status code is 204, which means no content. Our delete was successful. If it was not 204, then we throw a delete failed error. All right, pretty simple stuff so far. And that is our code for the network request. Now, inside of our view controller, I have an action for a delete projects button. This is going to work very similarly to how we toggled the status of projects excuse me, in our table. However, there's going to be one difference. Instead of toggling the status of our projects and all that, we're going to actually delete them. And we want the user to be able to delete more than one project at once. So we want them to be able to select as many as they want and then hit delete. So that means, much like when we were supporting multiple selections when toggling project status, we want to use what's called a task group to perform multiple deletes in parallel. So we're sending multiple requests to the server at the same time, and all those will be completed at different times depending on how long it takes. All right, so let's talk a little bit about why a task group here is useful as opposed to sending out a request one after another using, for example, a for loop. Well, if we were to go the for loop approach and send network requests one after another, they would be not only sent but performed synchronously. As in, each request would be done one after another, and you would have to wait for each one to be done before the next one can start. And that's not very useful. That's not very efficient. We want to have these sorts of things be as efficient as possible. And that's where a task group comes in. It is much more efficient to perform asynchronous tasks in parallel than it is to perform them one after another synchronously. That way we can get more work done at the same time. And the user doesn't have to wait as long. So that's why we're going to use a task group here. Now, there are two kinds of task groups that you can do with Swift concurrency, and that is a normal task group using with task group. That's a built-in method to Swift. Or you could use with throwing task group. And this should be used if the code for each task in the task group throws some kind of error, which we are going to use because our delete method inside of our network manager has the potential to throw errors. So we want to use a throwing task group instead of a normal task group. They are created the same way, however, you just use a different method signature. So, first things first. Inside of our delete project's action method, we will surround everything with a task. So we have an asynchronous context we can work with. Then we need to retrieve the selected row indexes in our table, and we will use those to map them to actual project instances from our projects array. So we'll say let's selected rows equals projects list dot selected rows, or selected row indexes rather. Now this could be empty, and we don't want to do anything if the array is empty. So we'll say guard exclamation mark selected rows dot is empty. Otherwise, we simply want to return. All right. So if the selected rows is empty, return, don't do anything. If it's not empty, then we can continue. We can continue on with what we're going to do here. Now, inside of our task, after we've checked to make sure that we actually have some selected rows, we want to create a do catch block. So do catch, and we will print error.localized description. And so inside of our do block, this is where we will create our, this is where we will go about creating our task group. So we'll say await with throwing task group. Now we need to tell it, if you're not using Swift 6, where it can, you need to provide the type that will be returned by the task group. In this case, it'll be void.self, because we're not going to return anything. Delete doesn't return anything, unlike our get projects method that returns an optional array of projects. This will return nothing. So we want void self as the type. If you're on Swift 6 and above, Swift can infer the type based on the first task that you add to the task group. Next, we need a body. And this body is a closure that gives us a group instance, like a task group instance, that we can work with. Now, inside of this closure, the first thing that we want to do is we want to map the indexes to actual project instances, right? So we want this to end up being an array of projects. We'll say let selected projects equals selected rows dot map, and it'll be, we want to return self dot projects at the given index, just like that. And now we have our array of projects. After we've done that, we want to loop through these projects. So for project in selected projects, you could also do a for each. Like, you could also call for each on the selected projects array, and that would work fine. But I'm going to use a for in loop here to keep it simple. So now what we want to do is we want to say try await, or not try await. We want to say group dot add task, and this add task method takes a closure. This closure is the work that we want to perform for each for the task in the task group. So for each task, we simply want to do the following: try await network manager dot shared dot delete, and then pass it our project. So delete project, just like that. So now let's say we have 4 projects. When this code is run, that 4 tasks will be added to a task group, and that task group will then be kicked off, and all the tasks will be run in parallel. If any errors are thrown, they will then the catch block will be reached, and any code in there will be executed. Pretty simple stuff this far. Now, once all of this is completed, we need to actually remove all of those projects from our projects array. So we can do that by saying so we can say selected rows dot map and we can say self dot projects $0. And then when we have that mapped, we can do a dot for each and for that inside of our for each we can do a self dot projects dot remove we can say remove all where $0 dot ID is equal to remove all where $0 ID is equal to project.id. So I'm going to put that on its own line. Okay. And we'll attach that like that. Okay. So now, what we're doing here is we are converting our selected rows to an array of projects in line. We're not storing it anywhere. And then after that, we are calling for each on that resulting array, and we're explicitly specifying a project argument. So then, inside of our for each, we are simply removing that project from our projects array. All right. And once we've done that, we can apply another snapshot, and we should be good to go. Okay, so it says something. Let's go ahead and see what this warning is here. Okay, so it says there's no error that gets thrown in the do block, but we have our URL, our network code marked as try. So we can, just to double check, I'm gonna go up to our toggle status method and make sure that our code is identical. Okay, so await with the right task group. Yeah. Okay, so yep, we've done that. For projects and projects to modify, yep. Group, add task. Try, await network manager, yeah, okay. Yeah, so everything should be fine. Theoretically. Await with throwing task group of void.self. Group in. Yep. Group add task. Yep, try. Await. Yeah. So we should be okay. Let's run our code. We have a successful build. So here we have all of our projects here. Let's select them all. So we have 4 rows selected. Let's hit delete. And you can see now everything is gone because we deleted all 4 of those projects from the server. We didn't get any errors or anything like that. They're all deleted from our projects array. We updated our table with a snapshot to the data source. And when we run our code again, the table should be empty. Now we can go into our terminal and you can see our server has logged 4 delete requests. And that's precisely what we wanted. So while Xcode is being odd and is saying that we aren't catching any errors in our do block, even though we are marking a statement with try, it does work, and that pretty much does it really for how we can utilize Swift in our macOS applications to send delete network requests to our third-party API, and with that also concludes our videos on the topic of network requests. Thank you all so very much for watching, and we'll see you in the next video.